going to talk about slope. This is part 2 of our slope series. Now, if I were to ask you if you're somebody's really good friend and you are going to take them skiing, and you have these 3 different hills, and your friend is a beginner skier, which one of these slopes would you take them on? You don't want them to hurt themselves, so you were going to get them on a ski slope that is not too steep. That is what slope is. Slope measures the steepness of a line. And so I've given you these 3 hills, and you're to figure out which one of these hills you're going to take your friend on who's a beginner. Well, it's got to be an easier way than just looking at it. It's hard to tell this way just by looking at it. So what I've done is I'm going to put these 3 hills onto a graph. And here they are. There's the blue one, the red one, and the green one. By looking at them, you can tell which one is the least steep. But can you tell which is the steepest? The red one looks less steep than the other 2. Now, the other 2 are very close. That's why, by just looking at something, it's very difficult to do. So how would we measure the steepness of a line, of a hill? If you look at this, it really depends on how high it goes and how far it goes horizontally. This is called the run, and this is called the rise. In this case, we have a rise equal to 60, and the run is equal to 110. Okay, now the other one, we've got a rise of 60 and a run of 70. And finally, the last one, the blue one, is a run of 100 and a rise right over here of 80. So can you think of a way to figure out numerically which one of these is the biggest slope to the smallest slope? Well, basically what we can do is use a formula for slope, and the slope is equal to the rise over the run. And so for the blue one, if we look at the blue one, okay, slope of the blue one is equal to 80 over 100. And if we measure that and calculate it, we get 0.8. If we look at the red one, we have a slope of 110 over 60. And if you calculate that one, you can use your calculator or you can reduce the fraction. What you'll get is, oh, now look at what I've done. Rise over run. I did the opposite. This is a common mistake with students. We wanted to do 60. I apologize for that. Here we go. 60 over 110, and that gives us 0.55 approximately. Okay. And so we know that the red one is less steep than the blue one. But we weren't certain about the blue and the green. So let's figure out the slope of the green. Remember, it's rise over run. And a common mistake is for students to mix those up. So the slope is the rise over the run, 60 over 70, and that is equal to 6 divided by 7, which gives us approximately 86. And therefore, looking at these three, the steepest is the green one, and the less steep is the red one. And so if you're a good friend, you would have taken your friend on this ski hill to begin. And then once you got really good, I guess the very last one would be that one. Now, this is great to do rise over run on a grid. However, the grid must go up in the equal intervals both ways, okay? And so if you don't have it set up like that, where you can't just count the squares and give you the rise over the run, there's got to be another way to do this. So let's look at, how did we get this number? Well, we took this number here, which is whatever is between 0 and 80. And then we divided by whatever is in between this number here, which is between 0 and 100. So that was the difference, and that's what we did. Okay. Suppose we didn't have a grid and we couldn't count the squares, or if a grid is not going up by the same scale on both the x and the y, and we were just given a line with these coordinates, or we were given a table of values with these coordinates, and we don't have anything to count. But what we found before with the rise and the run was that the rise was the difference in the vertical distance, and the run was the difference in the horizontal distance. And so the slope was the difference in vertical distance and the difference in the horizontal distance. And so how do you find that? How do you find the difference here? Well, these represent the vertical distances. So I can say 21 minus 15. And these represent the horizontal differences. So 7 minus 5. And so what I end up with is 21 minus 15, 6. 7 minus 5 is 2. And I get a slope which is equal to 3. And what this tells us is that for every time, for every 3 distances, whatever the units are, that our line goes up, it'll go across 1, because 3 is also 3 over 1. Rise and run. And so we can create an equation that will help us figure out slope when we don't have a grid, we don't have squares to count, and when the scales are not the same on the x and the y axis. I can show you what a slope of 3 is. Now if I were to show you a slope of 3, I can choose any point on the graph. I can choose a point here and go 1, 2, 3 across 1, 1, 2, 3 across 1, and do it that way. Now the one that I showed you previously was just some points that I made up on a grid that was not following any type of numerical system. I just put them down to show you that there's a way of finding slope without having a grid. Now I'm showing you that if I want to show a slope of 3, that's 3 over 1. So this is the rise, and this is the run. And so to get from one point to the next, we have to rise 3 and go across 1, rise 3 and go across 1. This is also, it's also equal to -3 over -1, because that's the same thing. When you're going in the negatives, you're going down then. So if I'm going to go from this point, I can go 1, 2, 3 down, and then to the left 1, and then again down and to the left 1. This is -3 and -1. And the other way was up 3. We were going up 3 and across to the right 1. And that's how you do that. So you can have any point on any grid, and if the grid goes numerically by ones up either way, then you can figure out any other point on the grid based on the slope, based on how much you have to rise and what the run is, or this one where you're going down and then to the left. So let's look. This is a positive slope. What do you think this one is? Let's just draw a line going this way. There's a line going that way. And so I want to know the slope of this line, and I don't know any points or anything, so I'm just going to pick a point here. And to see what I have to do to get to another point, so you want to find one line. So this is going down 3 and across 3. So in this case, I am going down 3 and then across 1. To the right is always a positive. To the left, it's negative. And again, 1, 2, 3, 1, 2, 3. You're going down 3 and to the right 3. Down 3 and to the right 3. And this can go on like this. And so my rise, I can write slope is equal to rise over run is equal to -3.